Hey everybody, Lars here. It is Friday night, July 21st. You don't need to be reminded that your proposals are due because I have received proposals from the 4 groups that need to put in. My guys who are auditing didn't send anything, but if they don't send anything, that's not a big deal. I got it from the top 4 groups, so I'm a happy camper. Over the weekend, I'll be looking at proposals and getting you some feedback and hopefully approvals as far as that's concerned. But that's not why we're here tonight. Tonight, we are here to do the second review video for Big Bad, but Not So Big and Not So Bad Unit 5. I'm going to shoot this one live. I like going over some stuff. I think object-oriented programming is a little bit different than what you're used to, obviously, the first couple of weeks. So I like giving you a lot of examples. If you read the slides, you see the dice or the die class. So you get to see that in action. Then you see the student records that I do, a more, I don't know, kind of businessy application of object orientation as far as a record is concerned. Then the last video you saw the bank account class. So you got to see how a bank account works. This go around, we're going to use a completely different class. So you've got 3 or 4 different examples that you're seeing working in action. You can grab the ones from the slides. You can use the ones in the videos to play around. So you're starting to get a feel for the fact that classes are blueprints, and then we take these blueprints and we get an actual real object, and we use that real object in our code to do all the things that we set up in the class when we created our constructors and we created our methods. I'm going to slurp some coffee. Then I'm going to bring up a piece of code that I have ready for us to rock and roll. This is a class I wrote probably a long time ago now. I usually use it every semester. It is a class for an animal. And what we're going to do, actually what I'm going to do right now, is I'm going to run the code, and we are going to trace through it. So you will get a chance to see yet another class in action. But then what we're going to do is we're going to go into really the topic of this video. And the topic of this video is to go over 2 ideas that come along with object orientation and object-oriented programming. One is inheritance, and the other is something called polymorphism. And we're going to look at them both by using this class and creating a new class that goes along with it. But first thing I'm going to do is I think I'm going to review how this animal class works so that we're reminded what we're doing when we use classes and we do object-oriented programming. So the first thing we're going to do is we're going to skip this because it's all comments, right? Playing with classes, doing whatever. Then what are we going to do? We're going to skip all of this because it's a class, and similar to a function with the def, we're going to put it in memory. We're not going to really use it right away. And as you're going to see later on in this unit, we can also take classes and put them in libraries like we did with our functions back when we wrote our harshed. But I'm getting ahead of myself. So right now, this is all being put in memory. Then that's a comment. Right here, the second to last line is really the first line that's getting considered when we run this program, which is kind of funny. I set up a variable. I call it animal. I assign it a call to go create an object, use the animal class, and give it the string Fido and the number 35. And just right here, without having examined the class yet, I don't know what that means. So what am I going to do? In this variable, I'm going to assign something that I create with the class animal. So let's go up here, class animal. What do I have here? I have my constructor, dunder and knit dunder. Okay, self, which we now know is my animal because it's in the middle of the program. Name, which is Fido, and weight, which is 35. So we got a fat cat here. My buddy Doug likes to say there's a lot of 50-pound cats at Rutgers. Because when you see a 50-pound cat, is it the cat's fault? No. It's the person who just doesn't stop feeding them. All right? It's their boss. It's the person who doesn't stop feeding that person. So usually when you get a crummy employee at Rutgers, it's not always the employee's fault. Sometimes it's because his boss let him get away with murder, or her boss let her get away with murder. I digress. All right, I should have made the cat 50 pounds. Maybe I will when we run the thing. Oh, well, we got an animal, so maybe I'll make my cat 50 pounds. So what do? I have an instance variable. You remember all this stuff from the past video. I have an instance variable. I'm going to give it name, which is Fido. I have an instance variable that holds weight. I'm going to give it 35. All right. And then I'm going to drop back down here because when I create the object, all I'm really doing is running the constructor method, which is dunder and knit dunder, as you know. So I go to this second line. I go print, and I go my animal, which is my variable. And then I say dot get name. So what happens there? Here I have my animal. What is that? It's a variable that holds an object that was created with an animal class. So I come up here to animal, and I go down the line, and I say, is there a get name? Yes, there is. So what do? I return the variable self.name, which was assigned what? Fido. So when I do the first thing in the print, I print Fido, which is right there. Then the second thing I do, same process. My animal dot get weight. My animal is what? It's a variable. It holds an object that was created with the animal class. I come up to the animal class. Is there a method called get weight? Yes, there is. So what do I return? The variable, in this case the instance variable, because every object will have its own, self.weight. Self.weight in this case is what? 35? Haboom. So I print 35. And there you go. Now if I wanted to, I could create another variable. I could call it A1, and I could make it equal to animal, and I could have an animal called Fred and make Fred 15 pounds, and then I could print A1 dot get name. And what would happen? I rerun it, and it prints Fred's name. Okay? So I can have more than one object. This class is a blueprint, and I can use it to build that variable, or the object that that variable points to. And then I can, again, create another object that that variable points to, and on down the line. That's how it works with object orientation. Okay? So it's not just that one thing. But now that we've gone through things, and I have an animal class, the animal class is kind of, I don't know, kind of boring, kind of vague in a sense. I mean, animal is pretty generic. Generic's a good word to use in this particular instance. So let's say I wanted to do something more specific. Let's say, I'm going to get rid of old Fred. You know what? I'm going to get rid of this too, because I can. Let's say I wanted to get more specific. You're going to find out from now until the end of this semester. We are now going to have so much code to deal with that it's not all going to fit on the screen. All right? That's a good thing. That means we're getting complex enough that you're going to have to, my God, I'm sweating like crazy in here. It's hot. It's like still 80 degrees. It's 10:30 at night, and it's like, hey, Alexa, what's the weather like?
In Metuchen, it's 86 degrees with clear skies.
86 degrees.
You can look for just a few clouds in the sky with a low of 73 degrees.
73 is not a low. How dare you speak to me that way, Alexa? Turn that blue light off. What are you going to do? Say something? I'll unplug you. Goodness gracious. Can you imagine getting snippy with me? 73 is not a low. Can you imagine a low of 73? That's awful. We need some air conditioning. Global warming is happening. All right. What if I want to create a class that's more specific? Let's say I want to create one for a cat. So let's say class cat. And then maybe you're for user. All right. Then I would do that. And then it's time for me to create my constructor. But I start thinking to myself, I kind of like the things that are going on in that animal class. Because it grabs the name, it grabs the weight. I have getters and setters there. It has a speak method that I could just, really quick change and make that cat say meow. So wouldn't it be nice if I could just somehow tell Python, hey, I'm going to create a new class, but give me all the stuff from that other class? Wouldn't that be cool? You know what? It is cool. And you can do it. And it's called inheritance. Maybe if I could spell it. In parentheses, after cat, I'm going to put the class name animal. And what is going to happen is I am going to inherit all of the functionality of the class animal. I'm not just going to inherit. I'm actually going to create an object. You're going to see when I do it. Now, the first thing we're going to do is we're going to do just what we did last time, is that we are going to create a constructor, and that constructor is going to take name, it's going to take weight, and it's going to take a new variable. We're going to, with our cats, we're going to give our cats a color. Okay? So now we're going to do our constructor. This is the important part about inheritance. We're inheriting from animal all of the stuff. So what do we want to do? We want to go up and call animal's constructor and actually get ourselves a little animal object that we can then build on top of. Think about it as having a little Mr. Potato Head. And then you add the things on top of Mr. Potato Head. That's what we're doing. Okay? A blank eyeless Mr. Potato Head is our animal class. We're going to create that object and then build on it when we inherit. So the first thing I'm going to do here is I'm actually going to call animal, and it's a weird way to do it, but you'll get used to it. I'm going to call the constructor of animal, and I'm going to run it, and I'm going to say self because I want to give it the variable name because it's going to be the cat's variable name, not an animal one. I'm going to give it name, and I'm going to give it weight. All right? So then it's going to create an object, like Fido, like the old animal did. But I have a new variable here, color. But we're going to treat color just like an instance variable because that's all it is. It's an instance variable in the cat objects. All right? Self.color equals color. And there we go. All right? So what we did was when we're creating a cat object, we're going to call the constructor for animal, get an animal object, and just slam color onto it. And boom, we're going to have a cat. Now, what are we missing? I mean, look up there. We got getters and setters for name and weight. We kind of need a getter and setter for color. So def get color. Self is good enough. And just return self.color. And then def set color, and we really don't use these much. Self and color. If you wanted to reset the color, you would use something like this. And then just say self.color equals color. All right, so now we have our getters and our setters. I think we're in pretty good shape. Okay? So I created a cat class. I inherited everything from animal. All right? And then, but I really just added color as an additional variable. And then I added getters and setters for it because it's new. I mean, name and weight, I can use the getters and setters for animal because I've inherited from it, okay? Now, there's one last thing we really want to do, and it's going to have more to do with polymorphism than it does with inheritance, but I'm going to do it right now just to be complete. I am going to write a new speak method, and I'm going to call it the speak. I'm going to call it the same name as it has in the other class, only this time I know it is for my cat. So I'm going to make my cat say meow. All right, and we're going to talk about that and kind of the ramifications of that in a second. But the first thing I'm going to do is I'm going to test my new class. And I'm going to say C1. I'm going to grab a cat. I'm going to call that cat Felix. And I am going to make Felix a 50-pound cat. And I'm going to color Felix orange. Okay? And then I'm going to do C1. No, actually what I'm going to do is I'm going to do print C1.get name and C1.get color. And then hopefully this is going to work, and I'm going to trace through it. And then after that, we will play around with polymorphism. But let's see if it works. And it does. Oh my goodness. All right, let's trace through this code. C1 is a variable. I want it to be assigned an object, and to create that object, I'm going to use the class cat. All right, I'm giving 3 parameters here: the string Felix, the integer 50, and the string orange. So let's go rock and roll. Do I have a class called cat? I sure do, but it's inheriting from a class called animal. Do I have a class called animal? I sure do. All right, so things are looking good. I come down here to the constructor because I'm creating an object, so I'm running the constructor class. Dunder init dunder. Self, which is the variable name of the thing that called it, C1. Name is Felix. Weight is 50. Color is orange. So what am I going to do? I'm going to call the animal constructor. Animal.dunder init dunder with C1, Felix, and 50. So I come up here, class animal, init, C1, Felix, 50. I take the variables self.name, make it equal to Felix, self.weight, and make it equal to weight. So up here in the animal object, we have self.name defined as Felix and self.weight defined as 50. I go back down to where the call was. I drop down and I say self.color equals color. What was color? Orange. So that variable is here in the cat object, but in the animal object that we created when we called the constructor there, we keep the other two variables, okay? All right, and that's it, all right? We're done with the constructor for cat, so we're done. We now have an object. It is pointed to, the C1 variable points to it, okay? And the name of the cat is Felix. The name in the object, the instance variable, the name is Felix. The weight is 50, 50-pound cat, and the color is orange. So now, and this is the important part, we go to the second line. Print C1.getName, C1.getColor. And as you can see here, we printed out Felix and orange. So we're in good shape. But they both did very different things. C1 is what? It's a variable. And it holds an object that was created with a cat class. So I want to look in the cat class and see if there's a getName method. So I go up here, cat. There's init, there's getColor, there's setColor, there's speed. There's no method that says getName. So what does Python do at this point? Python says, hey, wait a minute. Did cat inherit from something? And the answer is yes. It inherited from animal. So let's go up to animal. Does animal have a getName? There's it under. There it is. So getName, what do we do? Return self.name. Was self.name defined? It was. It was given the variable Felix when we called the animal constructor down here. Remember when we created the cat object. So what does this method do? It returns self.name. So self.name is returned here and then becomes part of that print line right there. That's where we get the Felix. Now, C1. What is C1? It is a variable and it is pointing to an object that was created with a cat class. So does the cat class have a method called getColor? I go to cat, there's a init, and boom, it does. There's getColor, because cat's going to take care of the object. It's the thing we added on. It's going to take care of itself. Okay, so we're in Fat City. What does it do? It returns self.color. Self.color was given orange when we ran the constructor. So it returns orange, and you can see orange right there. Okay? So that's basically how inheritance works. It's a way we could take a class that we already wrote and use it and just extend it. You'll see there actually a keyword extends comes in handy in other languages. Java, C++, blah, blah, blah. And we could use what we did already, which is a big thing in object orientation, code reuse. We want to take what we've written already and not have to write it all over again. We want to be able to go back and use it and just build a little on top of it. So you can imagine, design-wise, having a car class with just the basics, brakes, tires, boom, boom, boom. But then you would create a Ferrari class and inherit from car, and you would add all kinds of things. You'd add an air grabber. You'd add, extra parts. You'd add all of this stuff, blah, 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 blah. Okay? Same thing with boats. I remember in the slides I used the example of a boat blueprint. You would have a generic blueprint for a boat. But then, if you wanted to create your own, you would have a special class for a tugboat that would inherit from boat. A class for a cigarette boat that would inherit from boat. Something for a steamer like the Titanic would inherit from boat. Okay? So that's what we're doing here. We're going up a hierarchy, and we have a base class with a bunch of base functionality. We're going to inherit from that and add a little bit to it and be able to utilize that code and reuse that code as programmers and designers of this logic that's going to solve problems down the road. Okay? Now, so far, really, most of what we've been talking about has to do with inheritance. But this is a video about two different things. It's about inheritance. It is also about a concept called polymorphism. And when we deal with polymorphism, we're really dealing with these speak methods here. So, break down the word. What does polymorphism really stand for? Poly is many, and morph is what? Some people say change, and when things morph, they change. I get that, but an older, I think it's is it Greek morph? I don't think it's Latin. It may be Greek. It's the older thing for morph. The older definition for morph was form, a form of something. So polymorphism really means many forms. So something that does something can take many forms. It can do the same thing, but it can take different kinds of forms. And in this sense, with my animal class, which is really generic and really basic, and back in the day, animal would be something we call an abstract class, something that's never ever meant to be instantiated or made into a real object. It's something that's always meant to be built upon, right? We just put sound there, okay? So when I do it down here, I make the class say meow. So it has the same name, and you might think if I inherit, that's confusing, but it's not, because when I run speak for something I created with cat, it's always going to use the speak method here. Because remember how we're tracing things? Whenever you have a method, it always goes and looks first in the class where the object was created. So in essence, we do what's called overriding. We override this method right here, the speak sound. There's also a concept, we may get into it description-wise in the next video a little bit, called overloading. Python doesn't support overloading. I'll get into that probably in the next video. You can have methods actually in the same class with the same name, and the only thing that makes them different is their parameter list. Okay, a method name and the parameter list are called the method signature, and as long as you have a different signature, Java, C++, you can use multiple names. It's called overloading. Python doesn't support that. If you try to have a method with the same name twice in the same class, Python will tell you to go pound salt. Python will say, get out of here, that's crazy. There are ways around it. Overriding is one of those ways around it. You're going to see overriding again in the next video when we override some of the utility methods that you use to print your object out. I'm getting ahead of myself. So what I'm doing here really is I'm using the speak method. I'm going to do this. That prints itself, so I don't have to print it out. All I have to do is run the method. So I'm going to say C1 speak like that, and it should tell me meow. Let's see if the programming gods agree. They do. It says meow. So what's happening here when I run this? What's C1? C1 is a variable that points to an object that was created with the cat class. So I go up to the cat class and I say, do you have a method called speak? There's cat. There's its constructor. Get color. It does. What does speak do? Print meow. So it prints meow. Okay? Now, let's just suppose for 2 seconds, and with the magic of commenting things out, I can do that there is no speak in the cat class. What's going to happen then? It's going to print sound. Because what happens is C1 speak. C1 is what? The variable holds an object that was created with a cat class. Does the cat class have a method called speak? I come up here to cat. I see my constructor. Get color, set color. This is commented out, so it's not there anymore. So all of a sudden Python says, uh-oh, we're in trouble. But does cat inherit from anything? It does. It inherits from animal. So I go up to animal. Hey, do you have a method that says speak? Right there. What do we do with that? We print sound. Boom. And that's exactly what happened in this case. Okay. But if we override the method as we've done here, we catch that speak call before it gets up here to the abstract version. We catch it and correct it by giving this object the correct sound. A cat is meow, and if we have a dog class, actually you're going to see a dog class in the next video, but if we have a dog class, we make the dog say woof or bark or whatever the dog says. And that's how it works. So basically overriding something is basically just catching it while you're in the class that you created the object with. All right. It's almost like this is and you'll see with abstract classes that this would be like a placeholder. There'd actually be a comment after it that says, make sure to write one for yourself when you inherit from this class. Okay. You could even have, sometimes they would write the method, and the method would have just one command. It would say pass, which means it's blank. It does nothing. It's zero. And if you see a class in your future travels and there are defined methods and they just say pass, means you're supposed to override it. It means you're supposed to write one for yourself. But again, I digress. Then again, we're pretty much at the end of the video because I went over the two things that I wanted to go over. I wanted to go over inheritance and polymorphism, two ideas that come along with object-oriented programming. Inheritance is code reuse. It's basically saying, hey, I've got a class. I want to reuse it, and I just want to extend it a little bit. I want to build on top of things. So we had our animal class, and we said, look, we're gonna create some cat features, all right? And then what did we do? We instantiated it. We made our 50-pound cat. It's not the cat's fault. You give the cat a whole bunch of food, cat's going to eat a whole bunch of food, right? It's the owner's fault. Never mind. So we did that, and then we took a look at polymorphism. I just want you to see the example of polymorphism. This isn't the greatest example in the world. I just want you to get the idea that with object-oriented programming, different objects can have methods that have the same names, and that method's behavior will act differently depending on what it's part of, depending on the context. So if I say speak to a lion, it's going to say roar. If I run speak on a dog object, it's going to say woof. It's, you know, that's the idea behind it, is that you can create situations where different behaviors that distinguish, because remember we went over attributes and data is attributes and methods are behaviors. Just like the object you're doing, a behavior like the way something walks could be different, but it's the way it walks. So you want to describe it as a walk or a gait or something like that. All right? So that's where polymorphism comes in. So we can create things that have the same name, and it becomes useful because sometimes you just have a list of 20 objects. I don't know what they are, but I want them all to speak. So you throw them in a loop and you make them all speak, and you go, oh, look at that. I got 3 dogs. I got 2 cats. I got a pig. I saw an oink. I saw a moo. I saw a moo cow. You know? So sometimes that comes in handy as a programmer because I don't know what kind of objects are going to be running through my code sometimes. But if I use the speak method, I'm going to make that object sound off. All right? And whatever it is, it's going to give me that sound. All right? So that's kind of where polymorphism comes in. So inheritance, polymorphism, absorb it, learn it, live it. Python, good. Python, good. All right? All right, then I most certainly am not going to kill you with announcements right now because there's another video coming over this weekend. And you've all handed in your proposals. So you've all been excellent students. I'm going to review them in the next couple of days. I got a bike ride tomorrow. After the bike ride, I'll probably be exhausted. So if I don't fall asleep or I'm not in Kennedy Hospital getting a transfusion or fluids, then I will go over those proposals and send you suggestions, but most likely send you suggestions and approve because I know it's summer. We're truncated. Got to get you time so you can get your projects done. All right? Then I am not going to waste any more of your time, and I am going to get out of here. You be good, and I'm going to talk to you over the weekend. All right? All right. I'll see you later. Bye.